Welcome to the session on Workload Identity Federation in Kubernetes and Azure. Today, we will explore how Identity Federation works in Azure and its role in securing workloads. To fully understand the flow, we will first define Identity Federation and its significance. Next, we'll explore how service account functions in Kubernetes and how projected service account tokens differ from standard service accounts. After that, we will go through an overview of Workload Identity Federation, followed by a detailed explanation of how it works. Finally, we'll wrap up with a hands-on demo to see it all in action. Identity Federation. Now, let's take an overview of what Identity Federation is. To understand this concept, let's consider an example. Imagine an organization that uses Keycloak as its identity management system. A user is created in Keycloak and he wants to log into a third-party application, let's say Microsoft PowerPoint, using his credentials. However, PowerPoint relies on Microsoft's internal identity provider, Intra-ID, for authentication. Since PowerPoint has a trust relationship with Intra-ID, the user's login request is redirected there. At this point, Intra-ID cannot authenticate the user directly because it's not the Microsoft account, and their identity does not exist within Intra-ID. But by examining the email domain, Intra-ID can determine the user's identity provider. Since a trust relationship has already been established between Intra-ID and the organization's identity provider, Keycloak, the user is redirected to Keycloak for authentication. Keycloak then verifies the user's credentials and issues a token, let's call it T1. The user presents this token to Intra-ID, which internally validates it against Keycloak. Once verified, Intra-ID issues a new token, say T2, which the user then submits to PowerPoint. Because PowerPoint trusts Intra-ID, it verifies the token and grants access to the user. This entire process ensures seamless authentication across multiple identity providers while maintaining security and trust between different systems. I hope this was clear. Moving forward, Kubernetes service accounts and projected volume. To understand how Workload Identity Federation works in Kubernetes, we first need to understand how service accounts function in Kubernetes. Now let's take a look at what happens when a pod is created in Kubernetes. When a pod is launched, the Kubernetes API server uses the service account admission controller to check whether a custom service account has been specified. If a service account is provided, the API server verifies its existence. If no account is specified, Kubernetes assigns the default service account to the pod. Additionally, the service account admission controller automatically mounts a volume to the pod at /var/run/secrets/kubernetes.io/service account/token. This mounted token is a JSON web token, which allows the pod to authenticate with the Kubernetes API server. If we decode this JWT token, we can observe that it contains an audience field, which is set to the Kubernetes cluster server address. The audience field defines the intended recipient of the token, ensuring that only the correct service or API accepts it. Let's try to understand the significance of the audience field using the example. Consider there are two API services, User API and Admin API. Both are part of the same application, and there is a user having the JWT token where the audience field is set to User API. If the user sends the request to both the microservice and pass the same JWT token, both the API service verify the audience claim before accepting the token. If the audience field does not match the expected value, the token is considered invalid and the request is rejected. Projected service account tokens. By default, when a service account is assigned to a pod, the audience field in the JWT token is set to the Kubernetes server's address. That means the token can only be used to authenticate and interact with the Kubernetes API server. However, Kubernetes provides a technique called projected service account tokens, which allows us to specify a custom audience field. By using a projected volume, we can request a token with a specific audience field. This enables us to use the token for authentication with other services inside the cluster or even external protected resources. This capability is essential when integrating Kubernetes workloads with external identity providers, such as Azure Intra-ID, as we will see in the next sections. Now, let's dive into the main topic of the video and explore what Workload Identity Federation in Kubernetes and Azure is and how it functions. One of its primary use cases of workload identity is enabling Kubernetes workloads to securely access external protected resources. Consider a scenario where a pod running inside a Kubernetes cluster needs to access resources in Azure Cloud. There are multiple authentication methods available, but each comes with its own challenges. Using a username and password for authenticating is not secure, as credentials can be exposed or leaked. Using client ID and client secret is another approach, but securely storing and passing these credentials to the pod within the Kubernetes cluster is a challenge. Certificate-based authentication is also an option, but it introduces the complexity of managing certificates, including renewal and rotation when they expire. To overcome these limitations, we can leverage Workload Identity Federation. This approach provides a secure and seamless way for workloads running inside Kubernetes to authenticate with external identity providers, such as Azure Intra ID, without the need to store or manage long-lived credentials. Next in the demo, we will showcase the same process by accessing the Azure Key Vault from the Kubernetes cluster deployed in our local environment. First, we need to generate a private and public key pair. We'll use the OpenSSL command line utility to create these keys, which will later be used for signing and verifying tokens. Next, we need to create cloud storage to host our OIDC artifacts. Let's go to the Azure portal and create a new storage account. To ensure public accessibility, we need to enable blob anonymous access on the storage account. Now, we navigate to data storage and create a container named demo where we'll store our OIDC artifacts. OIDC artifacts consist of two key components: an OpenID configuration document, which provides metadata about the identity provider, and the public key we generated earlier, stored in a JSON Web Key Set document. Now, let's switch back to the terminal to create a JSON Web Key Set file. Now, let us upload jwks.json to our storage account. Let's verify that the upload was successful. Next, we create the OpenID configuration.json file. The issuer URL should be set to our storage account URL. One can find in the container URL and the Properties tab. The JWKS URL should point to the location of the public key, jwks.json. Once the OpenID configuration document is ready, we upload it to the .wellknown/openid configuration path in our storage container. Let's verify if upload was successful. We also need to change the access level of the container so that files in the demo container are publicly accessible. Finally, let's test access from the terminal by making a request to the OpenID configuration documents URL to confirm it's publicly reachable. Now our OpenID Connect artifacts are ready. Next, We need to create a Kubernetes cluster that will use the private and public keys we generated earlier. Since we are setting up a local cluster using kind, we first create a cluster configuration file. In this file, we mount the private and public keys inside the cluster nodes and modify the Kubernetes API server configuration. Specifically, we set the service account issuer and service account signing key files so that the service account tokens are signed using our custom private key. Now, we create the kind cluster using this configuration file. Now that the cluster is ready, we need to create an Azure Managed Identity and configure federated credentials, which will be later used to authenticate the protected resources. Let's go to the Azure portal and create a new Managed Identity. Once created, we configure federated credential. Federated credential scenario should be selected as Kubernetes accessing Azure resources. Cluster issuer would be the same as what we provided in the OpenID configuration doc. Namespace will be default. Service account should be custom. SA, this is the custom service account, which we will be creating next in the Kubernetes cluster. Name can be anything. Next, we will create a protected resource that is a key vault with some secret, which we will be accessing later from inside the Kubernetes pod. Let's go back to the Azure portal and create the key vault. Key vault is created. Let us go to the resource and create the secret. Now in access control, let us add role assignments and give permissions to our user-managed identity to access the key vault. Now, let's configure Kubernetes to use our managed identity for authentication. We will create a service account and we'll annotate it with the client ID of our managed identity. We start by creating a service account in Kubernetes named custom SA. And now we will be adding annotation azure.workload.identity/client ID. Next, we create a Kubernetes pod that uses the custom SA service account. In the pod specification, we also set the audience field to API/Azure AD token exchange. It should be the same what is there mentioned in the federated credential, which we created earlier. Once the pod is created, we wait for it to reach the running state. When a pod is created with the assigned service account, Kubernetes automatically mounts the JWT token inside the pod. We will exec into the pod and start the bash shell in the pod. You can see the service account token, which is signed by our private key, is attached to the pod. Now we can send this JWT token to Azure Intra ID. Intra ID will retrieve the public key from the OIDC artifact to verify the JWT token. Upon successful verification, Intra ID will respond with an access token. We can use the curl command to make an API call and to send the JWT token to Intra ID. You see we got the access token back in the response. Now we can use this access token to retrieve the secret from Azure Key Vault. We will use the curl command to call the Azure Key Vault API, and we'll use the access token in the authentication header. You see, we got our foobar secret in the response. I conclude the demo here. Thanks for watching.